this video, we're going to do an example where we use the first derivative test. So let's let f of x be the function x to the fourth minus 32x squared plus 75. And in a little bit, I'll graph this function on Desmos, but I want to do this problem without knowing beforehand what the graph looks like. And we want to find the intervals where f is increasing or decreasing. And then we want to list the critical numbers and use the first derivative test to classify those critical numbers as giving a local max, a local min, or neither. So how do we do this? Well, first of all, we're going to find f prime of x. F prime of x is 4x cubed minus 64x. And we want to find what values of x make this positive or negative. And to do that, we're going to find the values of x that make this 0. So how do we find the zeros of this? Well, we need to factor it. That's the easiest way. Notice both terms here, both of our two terms have an x in them, and they also both have a 4 in them. So we can factor out a 4x and write this as 4x times the quantity. Well, 4x times x squared will give us the 4x cubed, and minus 16, right? 4x times 16 will give you 64x. Now, this part in here, the x squared minus 16, that's a difference of squares, and that can also be factored. So x squared minus 16 factors to be x plus 4 times x minus 4. So again, what we're trying to do is find what values of x make this positive or negative. Well, and the easiest way to do that is to find the values of x that make this 0. Well, because of this factor, x equals 4 will be a 0. Because of this factor, x equals minus 4 will be a 0 of f prime. And because of this factor, 0 is a 0. Okay, if you plug in 0 here, that becomes 0. If you plug in minus 4, that's 0. If you plug in 4, that's 0. So we have our three numbers here. These are really the three critical numbers. And what we're going to do is use these critical numbers to draw a sign chart for f prime. So here's a number line. This is f prime. We're going to put the numbers on the number line. So the smallest one is negative 4, and the biggest one is 4, and the one in the middle is 0. And so at these critical numbers, f prime is 0. What about in between them and around them? So if we pick a number, let's say between 0 and 4, so say the number 3, and we plug it in up here for x, is f prime of 3 going to be positive or negative? Well, if we plug in 3 here, that'll be positive. That'll be 12. If we plug in 3, that'll be positive. If we plug in 3 here, that will be negative. So positive times negative, that's negative. Okay, in fact, that's true for any number that's between 0 and 4. So any number that's between 0 and 4, we're going to get a negative output. If we pick a number bigger than 4, let's say 5 or 100, just any number bigger than 4, plug it in here for x, that will be positive. Plug it in here, that will be positive, and that will be positive. So in all those cases, you get positive. Okay, so any number bigger than 4, if you plug it in, f prime will be positive. Now, between negative 4 and 0, so pick a number like negative 2. If you plug it in here, that'll be negative. This one will be positive, and this one will be negative. And so negative times negative, that is positive. Okay, so any number in between here is going to be positive. And likewise, it turns out if you plug in a number less than negative 4, like negative 5, all three of these will actually be negative, and a negative times a negative times a negative is negative. So we have a sign chart here for f prime. So what this tells us is that f prime is negative here. That means the original function f is decreasing. And since f prime is positive here, the original function is increasing. And then it's decreasing, then increasing. So our original function will be decreasing, then increasing, then decreasing, then increasing. So what we can say is that f is increasing on these two intervals. So first of all, we have the interval from minus 4 to 0. And we also have the interval from 4 to infinity. Okay, so f is increasing on these two open intervals. It is decreasing on, well, this interval over here is the interval from negative infinity to negative 4. And it's also decreasing on the interval from 0 to 4. Okay, so we found the intervals where the function is increasing, these two intervals, and where it's decreasing, these two intervals. So we've answered our first question here, find the intervals where f is increasing or decreasing. It says to list the critical numbers and use the first derivative test to classify them. Well, our critical numbers are these three numbers. They're negative 4, 0, and 4. Okay, those are the three critical numbers. Now let's use the first derivative test to classify those three critical numbers. So notice that negative 4, the original function is decreasing to the left of it and increasing to the right of it. So if it's going down, then up. Notice at -4, we're going to have a local min. So we have a local min at -4. At 0, well, the function is increasing and then decreasing. So we have a max at 0. And then also at 4, we're going to have a min, right? Because it's decreasing to the left of it and increasing to the right. So the original function is going down, then up, then down, then up. And so you can see that at 4, we also have a local min. Okay, so we've classified those critical numbers. Local max at 0, local min at -4 and 4. Now, here is the graph of the function on Desmos, and you can see at 4, we have this minimum. At 0, we have a maximum, and at -4, we also have a minimum, just like we thought. By the way, in order to see this graph, I had to change the y-axis here so that we could actually see things. Notice it goes down all the way to like -300 up to 300. The way I did that in here was I just made the x-axis go from -10 to 10, but I made the y-axis go -300 to 300. If I hadn't done that, if I had gone, say, from -10 to 10 for the y-axis, notice this is what the graph would look like. It goes down and then up and then down and then up, but it's just so hard to see because it's steep. So you have to change the scale on the y-axis. And after a little bit of fiddling around, I realized that -300 to 300 would give a pretty good view of the graph. Notice also that the function is decreasing on this interval from -infinity to -4. It's increasing on the interval from -4 to 0, right? The function's going up. And then it's decreasing again on the interval from 0 to 4, and then increasing again on the interval from 4 to infinity. Now, one thing more that we could do is say, what is the local max and what is the local min? So at 4, we have a local min. What is the local min? Well, as you can see, this is actually 4 comma -181. This one is -4 comma -181. And we have a local max at 0. The max itself is 75. So how could we find those numbers, 75 and -181 and -181, just based on the formula rather than on this Desmos graph? Well, what we would need to do is to plug in these numbers, the 0, -4, and 4, into this original function f. And as you can see, f of 0, if you plug in 0, you're going to get 0 to the 4th minus 32 times 0 squared. That's 0 plus 75. F of 0 is going to be 75. F of 4, if you work out the details, if you plug in 4 here, it's going to be -181. And same thing with f of -4. It turns out it's also -181. So if you plug that into a calculator there. So what we could say is that 75 is a local max and it occurs at 0. The way MyMathLab would say it is the function has a local max f of blank equals blank, and you'd have to put f of 0 equals 75. And it would say the function f has a local min f of blank equals blank, and you'd say f of 4 equals -181, and also f of -4 equals -181.